It is a Tuesday morning in Helsinki, and 6-year-old Aino is sitting on the floor of her kindergarten classroom. Around her, other children are building with wooden blocks. One group is negotiating the architecture of a bridge. Another is arguing about whether a stuffed rabbit should be the patient or the doctor. Aino is pouring imaginary tea into an invisible cup. Nobody is teaching her letters. Nobody is drilling phonics. Nobody is testing her on anything at all. And according to the research, her cognitive development is accelerating faster at this exact moment than any child sitting at a desk with a worksheet. She will not start formal academic instruction for another year. She will not see a standardized test until she is a teenager. And when she finally does sit for one, at age 15, alongside children from every developed nation on Earth, she will outperform nearly all of them. For years, the international data has pointed to the same uncomfortable conclusion. Nordic children score higher on measures of cognitive ability than children from countries that start formal academics years earlier. Finnish 15-year-olds consistently rank in the top tier of the PISA assessments, the gold standard for comparing cognitive performance across nations. Norwegian and Swedish children show stronger verbal reasoning. Danish kindergartners demonstrate superior executive function, and the gap does not close. It widens. For a long time, researchers assumed there were obvious explanations. Nordic countries are wealthy. They have universal health care. Low CHU0069 LD poverty. Highly educated parents. All of that is true. But when you control for those variables, something still remains. A practice so simple, so counterintuitive, and so thoroughly backed by neuroscience that most of the developed world continues to ignore it. Here is what the neuroscience says. Let me begin with the PISA data, because the numbers are not subtle. In the most recent assessment cycle, Finnish students ranked in the global top tier in reading, mathematics, and science. But the more interesting number is not the score itself. It is the relationship between the score and when those children began formal schooling. Across all participating nations, researchers can plot school starting age against test performance. The pattern is not what most people expect. Countries that push formal academic instruction to age 4 and 5 do not produce higher scores at 15. In many cases, they produce lower ones. And the countries that consistently sit at the top, Finland, Sweden, Norway, Denmark, all share one common policy. Formal academics do not begin until age 7. Now, a skeptic would say correlation is not causation. Maybe Nordic children are simply different. Maybe it is genetic. So let me give you the study that dismantles that objection. In 2019, a research team at the University of Copenhagen published findings that compared cognitive outcomes in Danish children. Denmark has a natural experiment built into its system. Because of a specific cutoff date, some children begin formal academics at age 6.5. Others begin at just over 7. Same country, same curriculum, same teachers, same socioeconomic distribution. The only difference was the age at which formal instruction began. The children who started later showed superior cognitive flexibility, stronger attention regulation, and higher scores on measures of executive function at age 11. The gap had not closed. It had grown. The extra year of play-based learning before formal academics had produced a measurable, lasting advantage. And the advantage was largest for children from lower-income backgrounds, the very children that early intervention advocates argued needed formal academics the soonest. The study did not suggest that children who started earlier were harmed. It suggested that children who started later were given something the others were not. And the research points to a specific neurological mechanism. Your child's prefrontal cortex is the part of the brain responsible for executive function, attention, regulation, impulse control, cognitive flexibility, working memory, the ability to hold a goal in mind and ignore distraction. Every one of those capacities predicts academic performance more strongly than IQ does, and the prefrontal cortex does not develop through direct instruction. It develops through something else entirely. Adele Diamond, one of the world's leading researchers on executive function at the University of British Columbia, has spent decades studying what builds this part of the brain. Her conclusion is unambiguous. Executive function is built through play, not structured drills, not flashcards, not worksheets. Play, particularly self-directed, imaginative social play, is the single most powerful driver of prefrontal cortex development in early childhood. When a child builds a block tower, they are not just stacking. They are planning, testing, failing, adjusting. That is the prefrontal cortex firing. When a child negotiates who gets to be the doctor and who is the patient in a pretend game, they are not just playing. They are inhibiting impulses, holding multiple perspectives, resolving conflict. That is the prefrontal cortex wiring itself. When a child pours imaginary tea into an invisible cup, they are not wasting time. They are engaging in symbolic representation, the cognitive foundation that reading, writing, and mathematics all depend on. And here is the part that should change how every parent and every policymaker thinks about early childhood. A meta-analysis published by Tubb and colleagues compared guided play against direct instruction for young children. The finding was consistent across studies. Children learned academic content just as well through guided play as through direct instruction. But the children in the play condition also gained something extra. They showed superior problem solving, greater creativity, and better transfer of learning to new situations. Direct instruction taught the content, play taught the content, and built the cognitive architecture to use it flexibly. The Nordic practice that explains the IQ gap is not a curriculum. It is not a set of workbooks. It is not an app. It is a decision. The decision to protect play. Between the ages of 3 and 7, Nordic kindergartens are organized around one organizing principle. Children play. They play outside in the snow. They play inside with blocks and paint and costumes. They play in groups. They play alone. They play for hours every single day, and the adults in the room are not there to direct them. They are there to observe, to support, and to get out of the way. Pasi Sahlberg, the Finnish educator who has written extensively about why Finland's system works, describes it this way. The most important sentence a Finnish educator ever wrote was not about testing or standards or accountability. It was this: children learn through play. Everything else in the system follows from those 4 words. Now, I want to address the question I know some of you are asking. Is this just about Finland? Is this a cultural thing that cannot be replicated? In 2023, researchers at Aarhus University in Denmark published findings on self-directed play and what they called cognitive flexibility. The study was not about comparing nations. It was about comparing children within the same Danish school system. The children who had the most daily unstructured playtime showed the strongest ability to switch between tasks, adapt to new rules, and solve problems creatively. And when the researchers controlled for every variable they could, family income, parental education, baseline cognitive ability, the play effect held. The mechanism is not cultural, it is neurological, and it operates the same way in a kindergarten in Copenhagen, a preschool in Oslo, and a playroom in any home on Earth where an adult makes the decision to protect unstructured time. There is something else, and it explains why early academic push can backfire even when it produces short-term gains that look impressive. A child who is drilled on letter recognition at age 4 will know more letters at age 5 than a child who spent that year playing. That is a fact, and it is the fact that gets cited by advocates of earlier is better. But when you follow both children to age 8, the gap in letter recognition has vanished. The child who played has caught up on every academic measure. But the play child still has something the early drill child does not. Stronger executive function, better self-regulation, higher intrinsic motivation to learn. The academic content gap closes in 18 months. The executive function gap widens every year. David Bjorklund, an evolutionary developmental psychologist, explains why this makes sense from an evolutionary perspective. Human childhood evolved to be long for a reason. Play is not a break from learning. Play is nature's learning mechanism. When you see a kitten pouncing on a leaf, you are not watching it waste time before real hunting instruction begins. You are watching it build the neural architecture that hunting depends on. The same is true of human children, and pushing academic instruction into a brain that is still wiring itself for self-regulation and flexibility is like drilling hunting theory into a kitten and wondering why it cannot catch anything. So what does this look like in practice? If you are a parent and your country does not wait until age 7, if your child is in a system that tests and drills and pushes academics at 4 and 5, what can you do? Here are 5 principles drawn directly from the Nordic model. None of them require moving to Helsinki. First, Protect unstructured time. The single most important variable in the research is not what kind of toys your CHU0069LD has. It is whether they have long, uninterrupted stretches of time to play without an adult directing the activity. The Aarhus data suggests the minimum threshold is around 90 minutes of continuous self-directed time, not 15 minutes between scheduled activities. A block of time large enough for a CHU0069LD to get bored, push through the boredom, and build something from their own mind. Second, go outside. Nordic kindergartens prioritize outdoor play in all weather. Rain, snow, wind. The outdoor environment provides loose parts, sticks, rocks, water, leaves, that are far more cognitively stimulating than most toys. A stick can be a wand, a sword, a bridge, a spoon. That symbolic flexibility is precisely what builds the neural pathways that cognitive tests measure, and the physical activity regulates stress. A child who has run around outside for an hour arrives at a learning task with a nervous system that is calm and ready. Third, delay screens. I will keep this short because the research is unanimous and most parents already know it. Screen time displaces playtime. Every hour on a tablet is an hour not spent building, pretending, negotiating, or problem-solving in the physical world. The prefrontal cortex needs three-dimensional interaction. A screen gives two. The gap matters. Fourth, let them be bored. This is the hardest one. When your child says, "I am bored," the instinct is to solve it. Give them an activity. Turn on a show. Hand them the tablet. But boredom is the doorway to self-directed play. It is the space where a child's mind, with nothing provided from outside, reaches inside and begins to generate its own content. That reaching is executive function in action. That is the prefrontal cortex firing. Every time you solve your child's boredom, you take that reaching away from them. Fifth, trust the research. The evidence is not ambiguous. It is not disputed by credible researchers. It is not culturally specific. Play builds the brain. Early academic pressure does not produce lasting cognitive advantage and may come at a cost to the very executive functions that predict long-term success. The Nordic countries did not discover a secret. They organized their society around a finding that the rest of the world keeps ignoring. And the finding is this: children do not need to be taught earlier. They need to be allowed to play longer. It is now 2:30 inches the afternoon in Helsinki. Aino's kindergarten day is ending. She spent the morning building a block city. She spent the afternoon outside, collecting pine cones and pretending they were treasure. Nobody taught her a single letter today. Nobody drilled her on numbers. Nobody tested her comprehension. And according to the neuroscience, her brain built something today that a worksheet could never produce. It built the capacity to focus, to adapt, to persevere through difficulty, to think flexibly and creatively. When she sits for her first standardized test in 9 years, she will not just recall fact. She will use the cognitive architecture that 9 years of protected play built inside her. And the data says she will outperform children who have been drilling since they were 4, not in spite of the years she spent playing. Because of them, the most important sentence a Finnish educator ever wrote was 4 words: children learn through play. Everything else follows from that. Everything. If this shifted how you see those hours of block towers and pretend tea parties, tap subscribe. Every week, we dig into the real science of what is happening inside your child's mind through the lens of the most research-backed parenting culture on Earth. No educational fads, no fear-based marketing, just what the data actually shows. And one more thing. What is the hardest part of protecting play in your home? The boredom? The mess? The pressure from family members who think your child should be drilling flashcards? Tell me in the comments. I read every single one in the first 24 hours.